Okay, so today we're looking at divisions of polynomials. So this is the Mathematics Extension 1 course. So the learning intention for today is to gain the knowledge of the skills of how to divide polynomials. So we're looking at really at long division. So you need to be able to do that and know what the terms dividend, divisor, quotient, and remainder is, and understand the term product of its linear factors, or product of its linear factors. Okay, so let us start. So we have a polynomial, it's p of x. It can be written, this polynomial can be written as a of x times by q of x plus r of x, where p of x is the dividend, a of x is the divisor, q of x is the quotient, and r of x is the remainder. So if you did long division, the stuff that goes in here, p of x will be the dividend, it's a product of its divisor with its quotient plus the remainder. Okay. One thing to note is, and I mentioned this before, the degree of the remainder is going to be always less than the degree of the divisor. Yeah, so if that was x to the power of 3, the remainder can't be x to the power of 4. It will have to be less than x to the power of 3. Yeah, if that was the divisor. Okay. So let's do some examples. We want to divide each polynomial, and we want to write it in this form. So here I've got 3x squared plus 2x plus 5, and it's been divided by x plus 4. So this is the dividend, and this is the divisor. And if we wrote it as a fraction, it would be 3x squared plus 2x plus 5 over x plus 4. Okay, but we're going to do long division. So we put the dividend in here. And the thing that you need to make sure is that it's decreasing in power. So we've got x squared, x constant. Okay, and we're dividing by x plus 4. I really only care about this x here at the moment. Okay, I ask myself, how many times does x go into 3x squared? Well, that's 3x. So then I times this with each term here. So 3x times x is 3x squared. And that would make sense because eventually I'm going to subtract this. And basically I want that to disappear. Yeah, and that's why that would make sense. So 3x plus 4 is 12x. Yeah. Now I get my x again, and I subtract, so that disappears. 2x minus 12x is minus 10x. And I bring down what's left of the dividend. All right. I got the x again. How many times does x go into negative 10x? Well, that's negative 10 times. So multiply that negative 10 with each term here. So negative 10 times x is negative 10x. Negative 10 times 4 is negative 40. And I'm going to subtract these two together. So negative 10 minus negative, that becomes a plus, that disappears. So 5 minus negative 40 becomes positive 45. Okay, so here I've got the divisor, I've got the quotient, and this is my remainder. So if I wanted to write it in this form, p of x is equal to a of x, q of x, plus r of x. So p of x was 3x squared plus 2x plus 5. And that is equal to a of x, the divisor, x plus 4, times by the quotient, 3x minus 10, plus the remainder. And that's the solution to that question. Another example. Let's do the same thing. So we want to now have x squared plus x minus 3 divided by x minus 2. So that becomes a dividend, x cubed plus x squared minus x minus 3. It is decreasing in terms, divided by x minus 2. So I asked, how many times does x go into x cubed? Well, that goes x squared times, and multiply that across. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And then minus that from each other. That disappears. 1 minus a negative, so 1 plus 2 becomes 3x squared. And I bring this down. Technically, I bring all of it down, but just to make it neat, I'm just going to bring the one term. If I had 5 terms here, then I'd bring all the next 5 terms. But at the moment, I just need these 2. All right. I asked myself, how many times does this x go into 3x squared? Well, that is 3x times. I multiplied 3x with x to give me 3x squared. I multiply 3x with negative 2, so that's negative 6x. And then I subtract. 3x minus 3x disappears. Minus 1x plus 6x becomes 5x minus 3. Bring it down. X goes into 5x 5 times. So 5 times x is 5x. 5 times negative 2 is negative 10. And I subtract them together. So negative 3, so 5x minus 5x disappears anyway. Negative 3 plus 10 is 7. So remember writing it as p of x equals a of x multiplied by q of x plus r of x. So x cubed plus x squared minus x minus 3 is the same as x minus 2 multiplied by x squared plus 3x plus 5 plus the remainder of 7. Okay. And now, if this was able to be factorized, I would factorize it, but I can't, so I'll leave it. That's the answer for that question. All right, question 10. X to the power 4 minus 2x plus 5x plus 4 divided by x by 3. All right. So x to the power 4 minus, now I'll stop here, because looking at this, I've got 4, then I've got a 2, 1 constant. I'm missing x to the power 3. So I'm going to write in 0 of x to the power of 3. Okay. Then I'm going to write negative 2x squared plus 5x plus 4. Okay. Oh, I forgot my divisor. X minus 3. So x goes into x to the power 4, x cubed times. X cubed times x is x to the power 4. X to the power 3 times negative 3 is negative 3x cubed. And that's why I needed that 0x cubed. So I'm going to subtract both of those together. That disappears. 0 minus negative becomes a positive. I'm going to bring that down. So x goes into 3x cubed, 3x squared times that across, 3x cubed, 3x squared times negative 3 is negative 9x squared, and minus these from each other. That cancels out. Negative 2 plus 9 becomes 7x squared. This 5x comes down. X goes into 7x squared, 7x times 7x squared minus 21x minus these 2 from each other. That disappears. 5 minus minus, another plus, so 5 plus 21 is 25x. So x, that goes into 20, bring the 4 down as well. So x goes into 25x 25 times. So 25x 25 minus 3 is negative 75. Minus those two together, we get 4 plus 75 is 79. So writing it in its polynomial form, x to the power of 4 minus 2x squared plus 5x plus 4 is equal to x minus 3 times by the divisor, the quotient, x cubed plus 3x squared plus 7x plus 25 plus 79. Looking at those, I think that's as fine as we're going to go for today. Okay, so that is how to do long division of polynomials and writing polynomials as a product. This is writing it as a product of its functions. Okay, thank you very much.